So, hello everyone. Um, today we are going to solve one DP problem that is cut into segments. So, in that problem, you are given an integer of an integer n denoting the length of the rod, and you need to determine the maximum number of segments you can make this rod, provided that each segment should be the length of x, y, or z. So we can understand it on the paper and pen. So we can take an example. So let's say L is equal to 7 and we have x, y, z like 5 to 2. So what basically we want to do? So already we have understand, like we have to segment this part in such a way the number of the segments should be maximum and the length of the each segment should be either 5 to 2. Okay, so let's understand its recursive tree. We have 7, we have x, y, z, which is 5 to 2. Okay, so now here we can use to segment this 7, we can use 5. We can use 5 or 2 or 2. First start with the 5. Let's 5. So what will be the remaining length? It will be 2. Now for this 2 we can use this 5 to segment length of segment. So for this, can we use 5? No, we have the length 2 and now we want to get a segment of length 5, which is not possible. So we are not going to use this part, we are going to use this 2. Can it is possible? 2. Yeah, so we are getting 0. So what is this? Like we have length 7, we use a segment of 5 length, and again we use the segment of 2 length, and now the length remaining length is equal to 0. So here we need no segment. Okay, so what this is also a solution. Then again we are going to here, because we only use these two, we need to get every and each possibility to get the maximum segments. So here what we are going to do, we again take two, this two, and again get 0. So this is also a, this is also a possible way. Okay, so now we return here, because we have checked through all the xyz. Now again go to there, and from here we can move for this 2. For 2 the remaining length will be 5. For this 5 we can again have 3 possibility. So when we are going with the 5 we will get 0 length. So when we are getting the 0 length, that's mean we have segmented this 7 length rod, and we get the 2 segments. Okay, which is one of the, this one is for 2 and this is 5. Okay, again it will go to this place, and again we will check for the 2. We check for the 2, we will get 3. Now for the 3 length of rod, we can also segment with this help of these 3 segment length. But we can't use 5, because we have a length of rod 3 and we can't make it a segment of length 5. Okay, so we can use 2. When we are using 2, we will get 1. Now again for 1 we have 5 to 2. Can we use 5? No, it's not possible. Already I have explained here. Can it is possible for 2? No. Can it is possible for 2? No, again no. Then it will get written from here. Now again the same process for the this 2. Okay. Now we will get 1, and again for 1 we have 3. Okay. So can we go for 5? No. 2? No. 2? No. Again we get return from here to here, and we have checked for all 3 possible. Okay, now again we will get return from here to here. Now again this 5 we will go for this 2. Now we will get 3, and also we have 5, 2, 2. The same process which we have done over here, we will do here. Okay. So if we see the whole thing, here we will get to know, like we have this one path, we have this one and this one segment, and we have this one and this one segment. Like we have 2 this path and 2 this path and 2. So what will be the max? The maximum will be 2. This is the basic answer. Okay, so let's understand it while coding. Okay, now in the same way, again we will move from here for these 2. Okay, for these 2, the remaining length will be 5, and again we have 3 possible way, 5, 2, 2. You can see the same thing which is here. Okay, so from there we got one possible way, so here also we get one possible way. Okay, because the 2 length are equal. Okay, now let's come to its implementation part. So for this recursion, what will be the base case? So if we talk about the base case, so when if length equal to 0, then if length equal to 0, we don't need to any segment. Okay, so we just return 0, and for that case, like we have after subtraction we get negative. For negative n, what we are going to do, we just n less than 0, we just return int min. This we will understand in the coding part. So this is our 2 base case. And for the recursion, what we are going to do, let's we are standing here. Okay, let's we are standing here, then how can we get this? We get this from n minus x. Okay, so in recursion part, let's we have a solve function. So here we are going to here we have solve function, where here we are going to n minus x, and what is same? This is same for all, so x, y, z. And one more thing, we are standing here, we are going to process from here, so we need to add this one segment. Okay, so here we need to add 1. So this is the our recursion function, for which this is for x. Okay, in the same way we have to find for y and z. Okay, now coming to the coding part, so we are going to write a recursion solution. So let's write int solve, where we are passing this, we can copy it from here. Okay, now put it there. Okay, so first we need to write the base case. Okay, so what will be the base case? Okay, so if n equal to 0, then what we are going to return? We are going to return 0. Okay, for negative, if our n less than 0, then what we are going to return? We are going to return int min. Why int min? You will get understand little while. Okay, so now recursion part. So what we are going to do now, we are going to get every possible way. So we are going to for process for the x. Okay, so let's we have an integer n p, and what we are going to do, we are going to solve what here we just do n minus x as I told you in the explanation, and we are passing x comma y comma z. Okay, and we need to add 1 over there. Okay, in the same way, control C, and the same way we are going to for this and this. Okay, so we need to write it P, Q and R. Now we get all the three possible ways, like for x, y and z we need to change here. Okay, for y and for z, but we want the maximum number. It is here told that we want maximum number of segments. Okay, so for that reason we are having an answer. What we are going to do, we're going to do find the max of what? P comma max of Q comma R. Okay, so once you get this answer, we are just going to return this answer. Okay, so, and yeah, we have okay, base case is completed. Now the recursion incomplete and maximum, we find the maximum. Okay, now in the main here, what we are going to do, what we need to do here, we just going to, you know, one int answer that will store our answer. Solve what n x y, sorry, y and z. Okay, now, okay, now what we are going to check like answer. Okay, we are going to check if our answer equal to what, if our answer what we are going to do, we just need to check if our answer not equal less than 0. Okay, if our answer is negative, we are just going to return what, we're just going to return 0. It is given in the question. Okay, so, and else what we are going to return, else we return our answer. Okay, so let's run this. What happened? Let's run this first. Okay, what intermin? Okay, we have to add there. Let me add there. Has include what? Limits dot h. Now let me run this again. Sorry. Okay, let's do submit. Okay, so it's showing TLE. So because this is the exponential time complexity, that for that reason it's showing time limit exceeded. So what we can do, we can use DP. So what we can do here, we just use vector int, which is DP, and we are taking n plus 1, and what we are going to do here, we are taking minus 1 as a. Okay, so in the same way we're just going to call, okay, int answer, we are just going to call what, solve function where we are providing what, we are just providing this n comma x comma y comma z and along with the dp. Okay, and now first okay, so here what we are going to do, we just have to store this value in the dp, so that if we if we get the same thing, we can utilize this value, like for the same, for the 6 length, how many segments is needed. So for that purpose we can use this. For this utilization we just have this in dp of what, dp of n. Why n? Because we just want to, like, for one length how many segments is needed, for two length how many segments is needed, for every length. That's why we are putting it in dp of n. Okay, now what we are going to do, we just need to return dp of what, n. And now we have to add the one more base case. If dp of n, dp of n, what, not equal to what, -1, then what we are going to do, we just return dp of n. Okay, okay. So just we are returning this, and here we have to check this. If our answer less than 0, we have to return 0. Else we can return, sorry, else we can return what, answer. Now let's do this. What is it is saying? Okay, we need to pass their dp also. Okay, and here also we can just copy this part from here and can paste over there. Okay, now run this code and let's see what. Okay, what I have written out. Okay, now I think everything is fine. Let me submit this code. Okay, it is also giving time limit exceed. So what we can do, I think we have to find out. Now let me run this again. Let me submit this again. Accepted. Okay, so we have to pass here reference. Okay, so we have what we have done here. Let's understand it again. Okay, so what we have did here, we include it's because of this int min. We have two base cases, like if n is equal to 0, then we will just return 0. If n is equal to negative, we just have what, int min. Because when we, why we are returning int min, because we can just ignore this part while taking the maximum. Okay, for that reason we are just managing with this negative with this return int min. Okay, now we are checking that if in the dp for this particular length, if there is no -1, that means there is existing solution for this length. We just return this segment. Otherwise we are just going for the recursive false for the x, y and z. And here we find the, actually if this solution is not exist, we just find the solution, we put it in the corresponding dp and then return this. Okay, now here we are what we are doing, we just initialize a vector where we have a -1, and we are taking here n plus 1, because in the in predefined we have 0 indexed base. So uh, for that reason we are just using a n plus 1, so that for this n it can be n plus 1. That is the only thing why we are using this. Okay, so now here we are just checking, like, if our answer is negative, that means there is no segments possible. So for that reason we are just returning 0, and otherwise we will just return our answer. So okay, thank you so much. If you like this video, please do like. Okay, thank you.